Hello everyone, this is Jiwon and today I'm going to talk about face recognition and its various methods along with each methods. Face recognition is one of the biometrics method that people use for identity verification and authentication. Face recognition can be categorized into two. One is face verification and the other one is face identification. First of all, face verification is one-on-one problem which simply compares two images and a given matching gives a matching result. On the other hand, face identification is one-to-one problem which compares the input image into multiple face images that are stored in the database. This identifies which personal is which. The face recognition process works as follows. It firstly detects the presence of a face on the given image. After that, it extracts the unique features from the detected face. And lastly, it performs the face recognition, and these methods will be introduced later on. Applications of face recognition includes passport, driver's license, video surveillance, and so on. As I said, face recognition is one of the biometrics method which identifies people with its unique feature, which is their face. There are other biometrics methods which utilize one's uniqueness, such as fingerprint, voice, signature, body shape, clothing pattern, and etc. Face recognition is advantageous in terms of contactless, especially in this COVID situation, and it's also secured, has a fast processing time, automated procedure, easy to adapt if you have a camera equipped with it. So here comes the classification of face recognition. So there are three big categories here: global, local, and hybrid methods. For global, they consider the whole face image as an input, and thus it is more of a general method. Local methods are more of focusing on each specific features on face, and they extract those. In case of hybrid method, they're more of combination of global and local methods. They are sometimes involved with machine learning methods and requires training. To add, we covered most of those major approaches in the lecture, so I will not go through details of each method while focus more on how they're different from each other. So there are a couple major tasks here that researchers have been trying to tackle. Those are the face variance caused by aging, facial expression, pose variation, and illumination effect. In case of partial occlusion, those are usually caused by people wearing accessories such as scarves and sunglasses. So first of all, variance caused by aging is difficult to tackle because the texture and shape of one's face changes over time. Gang et al. And Patterson et al. Have proposed both global and local approaches. They have proposed several PCA approaches which use the whole input and transform into an eigenvector. None of PCA method worked out that well, although it was slightly better than the pure PCA method. PCA methods are generally system efficient with its dimension reduction, while it is very sensitive to variance and thus reports poor accuracy. Lee et al. And Songatulina et al. Proposed local methods, LBP and SIFT, which extract features through binary representation and through feature vector. These feature-based methods are highly distinctive since they extract unique features from images, while they're not really system efficient since they need to tackle each region of the face. Another task comes here. Different facial expression cause difficulties in face recognition because it causes the movement of skin, tissues, and muscles in the face. So Ramachandran et al. And Retos et al. Proposed PCA approaches integrated with LDA and SVM respectively. After getting the subspace via PCA, methods will then use LDA and SVM classifiers for the recognition. So these combined methods are better than the pure methods since they minimize the drawbacks of each other. Bogara et al. Proposed SIFT matching with PFI that is similar to the human visual perception. It is efficient in terms of its runtime with the multi-layer classifier, but it is difficult to determine the optimal number of hidden neurons for MLP. Both global and hybrid methods have reported higher accuracy, like over 90%. So the third task is pose variation. This pose variation will change the location of significant features and thus make it difficult to recognize. Several researchers, including Zhang et al., tested eigenface method on pose-varying dataset. However, it did not turn out that well. Here, eigenface basically measures the difference between multiple face images using eigenvectors or feature vectors. It is still efficient because it does not require any pre-processing nor information. However, it has a very limited use since it is not tolerant to those uncontrolled dataset. So LBP was proposed as a local approach by Zhang et al. As well. As introduced earlier for the dealing with aging, LBP provides feature-specific information while limited because it considers everything to be important. In this light, detecting specific features and performing recognition turned out to be very effective compared to the general global approaches. So here, significant features are blocked by sunglasses and a scarf, and thus making it difficult to recognize. And this one, we call it as a partial occlusion. To tackle this partial occlusion problem, Kim et al. Tested both PCA and PCA with k-nearest neighbor methods. PCA still turned out with a poor performance with its zero tolerance on partially occluded dataset. However, a PCA method integrated with k-nearest neighbor reported a high accuracy by detecting occluded regions. Although this KNN step allowed higher accuracy, adding this additional step takes a slightly longer runtime. In this light, we can conclude that we need to tweak or add additional steps to improve accuracy and deal with the occluded regions as well. So lastly, here, different illumination effects cause either shadows or overexposure of face images, and thus making it difficult for the system to recognize one's face. So here, Chen et al. Proposed NMF, which showed slightly better performance than PCA. However, it takes longer time to converge when the image has a noise in it. Luo et al. Proposed another global approach, which is LDA, which considers the class structure unlike PCA. But as discussed, it shows poor performance with a small sample size. Feature-based SIFT approach was proposed by Turk et al. As mentioned earlier, it gives additional information on local features while it takes longer computational time. Most proposed methods generally work well because it only requires relighting or unlighting method to deal with illumination effect. After changing the illumination on the image, we can simply perform face recognition methods to do its job. So here are the main takeaways. Each method has both pros and cons, so we need to adapt those in a proper settings. Combining two methods or adding additional steps would cover up the drawbacks of the original method and increase the accuracy rate. For the future work, researchers need to make the processor and the runtime more efficient. And unlike testing under the standardized dataset, researchers need to improve the accuracy under the intense conditions. Lastly, these are the references that I have referred to throughout the presentation. And thanks for listening. As you can, and you can always request for the full text of my survey paper and this presentation slides. Thank you.